As a quick review of where we left off, Jasmine, we said this chapter, chapter 5, types of reactions. We're going to be looking at three main types. We're going to be looking at acids and bases, which are opposites of each other. We're going to be looking at salts. We're looking at organic compounds. Matt, don't try and write all this down all that fast. Just listen and you can get it later because I do throw this online. And for the next lesson, we're talking about acids and bases. We said there are other ways to classify things other than the most fundamental, ionic or covalent. You can classify them as to the type of compound there are. And one of the ways is by acidity. Acids, it turns out, and we watched a little video, release protons. Now, a short way you can write P+, but because they're coming from actual atoms, we say the protons are positive hydrogen atoms. If you look at a hydrogen atom is one proton and one electron. Take away the electron to make it an H+ ion. What's left? A proton. Why don't we just write P+, Mr. Dueck? Well, we write P+ if the proton is on its own, but if it came from hydrogen, we're saying it's actually technically a hydrogen atom. But Cameron, it's identical to a proton. It's going to behave that way. Acids release protons when they're dissolved in water. What are some acids? Orange juice, soft drinks, lemon juice. In fact, we said acids taste sour, which we kind of like in limits. Stomach acids are a much stronger type of acid. That's HCl. And we talked about the opposite of acids, bases. Bases are slippery, bleach, oven cleaner, and they're going to be on the other side of the pH scale. The key idea that we talked about was pH, which stands for power of hydrogen, which is also why we say H+ ions instead of protons. The more hydrogen ions, the more acidic. The less hydrogen ions, the less acidic. Neutral is at pH 7. Why isn't it at pH 0, Mr. Dueck? Because they didn't want to have a negative number for pH, because a negative number would suggest you had no hydrogen ion. You do. So I gave you a yellow piece of paper, which you probably want in front of you, and it has this chart on it. What's really, really basic? Oven cleaner. So basic, it'll corrode your skin. What's really, really acid or acidic? Stomach acid. So acidic, it'll burn your skin. But both of them are bad. So as you go away from a neutral pH of 7, as you move further out in either direction, Tyra, bad things happen if your skin is exposed. We will be doing a lab playing with some of these, and we're going to be extraordinarily paranoid about eye protection. Even one little drop probably won't do permanent damage, but I don't want to take a chance. Okay? So pH goes from 0 to 14. Less than 7 is acid. You don't have to memorize that, Ryland. You can just read it from your sheet. So if you look at your yellow sheet, it does have this little, and it does say acid over on the left. But you have to be able to interpret it. And bases, what's the fancy word for basic? Also begins with the letter A? Alkaline. Alkaline. Now, the key idea we said, Jasmine, with the pH scale is going up or down by 1 actually is going by a power of 10. In other words, the difference between bananas and water is 2 in the acid direction. Bananas are 100 times more acidic than water. Or tomatoes are 100 times more acidic than milk. Or if I want to go in the basic direction, I'll go up by 1, 2, 3. Oven cleaner is 1,000 times more basic than soap. More alkaline than soap. You can go now. So we talked about the pH scale. Then we talked about pH indicators. These are chemicals that actually change color in various pHs. You also have this chart on your yellow sheet. Unfortunately, the chart that you have is not in color, but the colors are labeled so you can kind of figure it out, right? You guys, your attention spans back here. Is everybody, oh, grade 12 walking out? They're not that special, trust me. We talked about different ones that change different colors, and I think we left off right here. Pause here. Okay? I said, Mr. Dueck, it would sure be handy to have these on a single page lined up with a nice pH scale chart. You've got it. The yellow sheet. Put your pencils down. little video to show you. So, folks, back here now. What did you say? What is the pH scale? Alex? Shh. What is the pH scale?
A scale that shows acidity and alkalinity.
Scale shows acidity and alkalinity. Okay. Acidity and basicness. Okay? Key idea, above what pH level is a solution said to be basic or alkaline? Where's the middle, not 0? 7. Do you need to memorize that? No, it's on your chart. You do need to understand that. Put the phone away, Matt. You're not that important. When a pH rises from 10 to 12, how many times more acid has the solution become, or basic, sorry, because that's in the basic direction, has the solution become? Not 2 times. What? 1 with 2 zeros. Okay? Why did we have to do that? Because if we didn't, that little chart would be wider than this room. We have to go up by powers of 10. Otherwise, we just can't fit it all on one nice piece of paper. What color is litmus paper in an acidic solution? Pinkish reddish. We call it red on there. Is it red or pink? I think I said red on there. It is kind of a pinky color. What color is bromothymol blue at the following pH levels? pH 5, I know. What color is it there? Yellow. What about C, pH 9? What color is it there? Blue. What would it be, pH 7? Probably a little yellow, probably a little greenish maybe, but I don't know. I need to run the experiment to find out. Okay? Back to our notes. So here's where we left off. I said answer below. Did we just answer those questions ourselves? Do we need to write out the answers, Matt? Well, then let's keep going. Next page. Oh, homework, I said pH color change worksheet. Did I hear a bad word there? I hope I didn't hear a bad word there. No, because if I had heard a bad word there, I'd be coming over the sink at you right now with this gun waving in midair. But I'm not, so I must not have heard a bad word there. What do we got? 15 minutes. Give me a second. I may pause here and just let you work on the homework instead. Hang on. Mr. Dueck, you said we didn't have any homework. You know what? I think you can, in fact, I'm almost positive. Shh. I'm almost positive you can get this part done in the 10 minutes that are left. This is a pH color change worksheet. I did put the answers on the back. Don't cheat. You're going to want that yellow sheet in front of you. By the way, the yellow sheet is better than the notes because I lined up both the charts so that the numbers match the pH. It's easier to read. So this is saying complete the following tables by using the figures shown on the previous page. Actually, the previous page is the yellow sheet that I gave you. Identify whether the substance is an acid or a base and indicate what color the pH indicator would turn. So look at lemon, write down its pH level, acid or base, and then see if you can deduce, Alex, thank you, see if you can deduce what color methyl orange, bromothymol blue, and litmus would be. If you get stuck, you can flip the page over and look at the back, but I think you can work your way through these. Then number 2 says, complete the following table. I'm giving you various pHs that you haven't seen yet. Tell me whether it's an acid or base, and then I'm going to give you a pH indicator. Tell me what color the pH indicator would turn if we dropped it in that substance. Alex, I think you can get it done in the 10 minutes that are left. Okay? So I'm going to pause here.